We've been linking the idea of demand functions to demand curves in the last two graphs. In graph 9.8, we linked it to the idea of an income demand curve or an angle curve. And in graph 9.9, we linked the idea of a demand function to that of an own price demand curve. In each case, we found that demand curves are simply slices of inverse demand functions. The same will be true for the last type of demand curve, the cross-price demand curve. We begin with the cross-price demand curves for Cobb-Douglas tastes. These are unusual because they are simply vertical straight lines. You can see why by just looking at the demand functions derived from Cobb-Douglas tastes in equation 9.4 of the text. There we find that demand for x1 is equal to alpha times I divided by P1. P2, the price of the other good, doesn't appear in the demand function for good x1, and similarly P1 doesn't appear in the demand function for good x2. In other words, there is no cross-price relationship. The prices of other goods in Cobb-Douglas tastes are irrelevant for the demand of a particular good. The only thing that matters is the person's income and the price of that good. The Cobb-Douglas function in the last two graphs, for instance, had alpha equal to 0.75. If we now assume an income of 100 and the price for good 1 equal to 5, we get from the demand function that x1 is equal to 0.75 times 100 divided by 5, which is equal to 15. Thus, no matter what value P2 takes on the vertical axis, the demand for good x1 will be equal to 15 if the income is 100 and the price of good 1 is 5. If the price of good 1 drops to 3, then the demand function tells us that x1 is equal to 0.75 times 100 divided by 3, which gives us 25. Thus, the cross-price demand function shifts to the right as the price of good 1 drops, but it remains vertical because P2 still does not appear in the demand function for good x1. And if the price of good 1 drops further, we get a further rightward shift in the cross-price demand curve. Similarly, if we increased income, we'd get rightward shifts in this cross-price demand curve, or if we decreased income, we'd get a leftward shift. But no matter what we do, the price of good 2 will not matter, and therefore all these cross-price demand curves will be vertical straight lines. To uncover more interesting cross-price behavior, we therefore have to move away from the Cobb-Douglas utility functions. In panel B, we consider different cases of constant elasticity of substitution utility functions. We begin with this green cross-price demand curve that emerges when the parameter rho in the constant elasticity of substitution utility function is set to 0.5. This translates to an elasticity of substitution of 0.67, because the elasticity of substitution is 1 divided by 1 plus rho. We also show here, as well as in the text, the demand functions that we derive from constant elasticity of substitution functions. And in this graph we've set alpha equal to 0.75, the price of good 1 equal to 3, and income equal to 100. Suppose now that we change rho to 0, and we leave everything else the same. In that case, we get this new blue vertical cross-price demand curve that looks exactly identical to the one we got in panel A when alpha was equal to 0.75, income was equal to 100, and the price of good 1 was equal to 3, as we've assumed here. This is of course no accident. When rho is equal to 0, the constant elasticity of substitution utility function converges to that of a Cobb-Douglas utility function, with elasticity of substitution equal to 1. Finally, suppose we let rho equal to minus 0.5, which gives us an elasticity of substitution equal to 2. The resulting cross-price demand curve then has an upward slope and is pictured here as the magenta curve. When all is said and done, this should make intuitive sense once you think about substitution and income effects. If the price of good 2 goes up, then the substitution effect says consume less of x2, which has become more expensive, and more of x1, which has become relatively cheaper. Thus the substitution effect says an increase in the price of good 2 should cause an increase in the consumption of good 1. The income effect, on the other hand, says that an increase in the price of good 2 lowers our real income. And if both goods are normal goods, this implies that as the price of good 2 goes up, we should consume less of both goods. Thus, an increase in the price of good 2 should give rise to an income effect that says consume less of good 1. The substitution effect, therefore, points towards a positive slope for the cross-price demand curve, because an increase in the price of good 2 should cause an increase in the consumption of good 1 according to the substitution effect. The income effect, on the other hand, points towards a negative slope for the cross-price demand curve, suggesting that an increase in the price of good 2 should lower our consumption of x1. If the substitution effect is relatively small, as it is when the elasticity of substitution is relatively small, the income effect will dominate and the slope will be downward sloping. If, on the other hand, the substitution effect is big, as it is when the elasticity of substitution is big, then the substitution effect dominates, and so does the positive slope. The Cobb-Douglas case, with its elasticity of substitution of 1, is the exact borderline case, the case where the income effect is exactly offset by the substitution effect, and therefore the cross-price demand curve is perfectly vertical, neither downward sloping nor upward sloping.